Hey guys and girls, in today's video I'm going to be showing you how to make a tool that allows you to cut parts into pieces. In order to achieve the slice effect, we're going to be using the subtract async function. What this function does is allows you to subtract parts from another part, and it will create a union. So here we can see on this image we have a yellow part and we're subtracting the pink parts to achieve this new shape here. Now if we imagine that this green block is the part that we want to slice and the player wants to slice along this pink line, what we would do is we'll create a part like this and we'll subtract this orange part from the green part so that only the bottom half of the part will be remaining, and then we'll do the same again but this time from this side like so, and we'll subtract this part from the green part and it will have only the top half remaining. In the first half of this video I'm going to be showing you how to design the tool, and in the second half of the video I'm going to be showing you how to script the slice. So the first thing I'm going to do is create a tool into the workspace, and inside of this tool I'm going to create a part, and I'm going to rename this part to be called handle. I'm now going to change the tool's color to a brown color, and I'm going to set the size to 2, 0.3, 0.3. I'm going to adjust the position to -8, 4 and 0. I'm going to increase this to -12, and I'm going to rotate on the z-axis by 90 degrees, and I'm going to change the shape to a cylinder. I'm now going to create the top of the tool, so I'm going to create a new part, and I'm going to call this top, and I'm going to set the color to a green color, and I'm going to change the material to neon, and then I'm going to change the size to 0.75, 0.75, 0.75, and I'm going to position it in the same position where the handle is, and then I'm going to bring it up like so. I'm now going to weld the top to the handle, so inside of the top I'm going to create a weld constraint, and I'm going to set part 0 to the top and part 1 to the handle. And now let's create the target part. So I'm going to create a new part, and I'm going to change the material to neon again, and I'm going to set the size to 0.5, 0.5, 0.5. I'm going to position this part in the same position as the top, and I'm going to move it slightly forward, and I'm going to change the shape to a ball. I'm also going to set can collide to false, can query to false, and can touch to false, and I'm also going to rename this part to be called target. I'm now going to create a beam that goes from the top to the target. So inside of the top I'm going to create an attachment, and inside of the target I'm going to create an attachment, and inside of the tool I'm going to create a beam, and I'm going to set attachment 0 to the top attachment and attachment 1 to target attachment. I'm now going to set a texture for my beam, so I'm going to open Toolbox, and under Images I'm going to search for beam, and I'm going to copy this image here, so copy the asset ID, and I'm going to paste it into the beam's texture. I'm now going to adjust the beam's width, so I want the width to be 1.2, and I want the beam to go down to 0.6. And I'm next going to reduce the segments down to 1, and I'm going to set face camera to true, and I'm going to change light emission to 1, and I'm also going to select the color and press this button over here to the right, and I'm going to set the start of the color to be green, and press close. I'm now going to create a particle emitter for the target. So inside of the attachment I'm going to create a particle emitter, and I'm going to set light emit to 1, and I'm going to change the size, and I think I'm going to have it slightly increase to 2, and then I'm going to change the transparency, and I want the particles to slowly fade out, and then I'm going to change lifetime to 1 to 2, I think I'm going to reduce the lifetime even more, so 0.6 to 1, and I'm going to set the rate to 40, and I'm going to set the rotation from negative 180 to positive 180, and the rotation speed from negative 40 to positive 40, and I want the speed from, let's say, 4 to 6, and I'm going to set the spread angle to be 180, 180. I'm going to set the drag to 0.5. I think I'm going to slightly change how the size of the particles are. So instead of increasing the size to 2, I'm going to reduce the size to 0. And now my particles look like this. And I'm also going to create a particle effect for the top of the tool. So inside of this attachment, create a new particle emitter. And inside of Toolbox, I'm going to search for particle under images, and I'm going to use this particle twirl image. So I'm going to right click, copy asset ID, and paste it into the texture. And for the top particle emitter, I'm going to set the color to be green, like so. And I'm going to change the size, and I want the size to start at 0, and then I want it to go up to 2, but I also want it to have an envelope of 1. So that means it will have a random size between 1 and 3. I also want the transparency to fade out, so I'm going to change this to this. The next thing I want to change is I want the lifetime to be between 1 and 2, and I want the rate to be 5, and I want the rotation to be from negative 180 to 180, and I want the speed to be 0. So now we can see the particle emitter looks like this. And finally, I want to say locked to part. Now if we play the game and pick up the tool, you'll notice that we hold the tool incorrectly. So now let's fix this. Inside of the tool, I'm going to change the right and up grip. So instead of being 1 0 0, it's going to be 0 1 0, and for the grip up, it's going to be 1 0 0. Make sure if this goes to negative, make sure to change this back to 1, like this. And I also want to slightly adjust the grip position, so from 0 to negative 0.3, like this. And so if I test the game again, we can now see that I hold the tool correctly. Another problem we have is that the beam has disappeared, and that is because the target part has no collisions, so it's fallen down to negative 500 and got destroyed. So we need to make sure to anchor the target part. So if we go down to anchored and set it to true, and we can now see that the beam doesn't disappear, and we can move around and the beam stays anchored to a single point. I'm now going to create a local script inside of the tool and delete this first line here, and I'm now going to get a reference to the tool. Now normally most people use activated and deactivated to determine when the tool was used, but we're not going to do this, and the reason for this is, so here you can see that I'm holding a tool, and if I push my mouse button down it says activated, and if I release the mouse button it says deactivated. But the problem is, if I activate the tool and move my mouse to a GUI and release the mouse button, we can see that deactivated was not called, and if I activate it again and deactivate, now you can see that activated was called 2 times in a row, and one of the deactivated is missing. And on mobile, if I click and drag, we can see that the tool is not activated or deactivated, but if I click, then we can see that activated and deactivated gets called quickly. So I'm unable to drag the tool if we use activated and deactivated events. So that's the reason why I'm not going to be using the activated and deactivated events in this script, but I will be using the equipped event, like so, and I will also be using the unequipped event. And I'm now going to get the user input service, and I'm now going to create a function called input begin, and I'm going to create a variable called connection input begin equals nil. And now when we equip the tool, I'm going to connect the input begin function, and when we unequip the tool, I'm going to disconnect the input begin function. Now, to prevent this input begin function being called when the player clicks on a GUI, I'm going to check the processed variable, and if processed is equal to true, then I'm going to return out of the function early and prevent it from continuing. I'm then going to check if the input type is mouse or if the input type is touch. And if it is not mouse or touch, then we're going to return and exit out of this function early. And now I'm going to print activated. And if we test the game now, if we push the mouse button down, it says activated, but if we release the mouse button, it doesn't say deactivated. So I'm now going to create a new variable called connection input ended equals nil. I'm now going to create a new function called input ended. I'm now going to connect the input ended function. So inside of input begin, I'm going to say connection input ended equals, and I'm going to connect the function. We now have a slight problem where the input ended function will be called whenever any input ends, but we only want the input ending function to be called when the input that activated the tool ends. So what I'm going to do is create a new variable called user input equals nil, and when the tool is activated, I'm going to save the input into the user input variable. And now inside of input ended, I'm going to check to make sure that the input is the same input that activated the tool, and if it's not, we're going to return out of the function early. But if the input is the same as the input that activated the tool, I'm going to set user input back to nil, and I'm going to disconnect the input ended function. And now I'm going to print deactivated. And if we test the game again, I can click and release my mouse button to see activated and deactivated, and the problem of activating and bringing the mouse onto the GUI and releasing the click is fixed. We can see now it gets deactivated. And if we test in mobile mode, I can click the mouse down and we can see that it gets activated, and if I release the mouse, it gets deactivated. We also have another small problem where if a player has a mouse and a touch screen, they could activate the tool twice in a row without deactivating. So in order to prevent this, what I'm going to do at the very top of the function, I'm going to check to make sure that the user input is equal to nil. If it's not equal to nil, we're we're going to exit this function early and prevent them from activating the tool twice. And now the next thing I want to do is have a heartbeat loop when the tool is activated. So the first thing I'm going to do is get the run service, and I'm now going to create a function called loop, and I'm now going to create a new variable called connection loop equals nil, and when the tool is activated I'm going to connect the loop to the heartbeat event, and when the tool is deactivated I'm going to disconnect the heartbeat loop. So if I delete this print here and this print here and create a new print inside of here like so, and if we test again, when I push the mouse button down we can see that it starts looping, and when I release the mouse button it stops looping. Now inside of this loop I want to get the mouse hit position so that I know where to position the target part. Now most people would use the mouse hit property to get the mouse's position in 3D space, but if we read the top here we can see that mouse was superseded by user input service, and Roblox strongly recommends that we don't use mouse anymore. So I'm going to show you how to get the mouse's position without using the mouse class. So the first thing I'm going to do is create a new function called raycast. I'm then going to use the user input service to get the mouse's position. I'm now going to use the camera's viewport point to ray function. So to do this we do ray equals game workspace.current camera, and we're going to pass the mouse's X and Y position into this function. The next thing I'm going to need is raycast perims. So I'm going to do this at the top over here. Say raycast perims equals raycast perims.new, and I'm now going to use this ray variable to cast a ray. So the ray will start at the camera's mouse position and it will shoot in the direction for 100 studs, and we're using the raycast perims that we created up here. I'm now going to check the result, and if the result equals nil that means the ray never hit anything. So if result equals nil, and if the result is not equal to nil that means the ray hit something. So if the result is equal to nil I'm going to use the ray to calculate the position. So to do this I'm going to say ray.origin plus ray.direction, and I'm going to multiply it by 100, the same I did here, and that will give me the position at the end of the ray. But if the result does exist, meaning the ray hits something, I'm going to return the results position and the results instance, so the part that we hit. And now that we've created this new function, I can use this function inside of our loop to quickly get the position and instance of the mouse. I now want to send this position to the server so that the server can position the target part for everyone to see where I'm using the tool. So to do this I'm going to create a new remote event, and I'm going to call this position event. And now I'm going to create a new script inside of the tool and delete this line here. So the first thing I'm going to do is get a reference to the tool. I'm then going to get a reference to the target part. I am now going to connect a function to the position event, and when we receive a position I'm going to simply position the target, and I want to print event. And now inside of the local script where we get the position from the raycast, I'm going to send an event to the server using the position event, and I'm going to pass the position into the event, and I'm going to delete this print here. And if we now test again, we can see that the target is fixed at a position, but if I start the heartbeat loop, we can see that we're sending events to the server, and the server is positioning the target at the position that the client is telling the server to position it in. You may notice that we're sending hundreds of events very quickly to the server, and we may want to throttle this so that we don't overwhelm the server with too many events. So I'm first going to create a new variable called server position, and then when the player activates the tool, I'm going to set the server position using the raycast function. I'm then going to send the server position to the server using the position event. And instead of blindly sending the position every frame, I'm going to check to make sure that the magnitude between the server position and the current position is greater than 8. And if the magnitude is greater than 8, I'm going to update the server position, and I'm going to send the updated position to the server. And now we can see that as soon as I activate the tool, the position is sent, and as I drag my finger around, every 8 studs the position is updated to the server. Now, instead of the target being visible all the time, let's make it so that the target is only visible when the tool is activated. So at the top of the server script, I'm going to say tool target.parent equals nil, and inside of the event, if the position equals nil, I'm going to hide the target, like this, and if the position is not nil, I'm going to position the target and set the target's parent to the tool. And now inside of the local script, when the tool is deactivated, I'm going to send an event to the server with the value of nil so that the server can hide the target part. And now you can see there is no target on the tool, and when I click, the target appears, and when I release the mouse button, the target disappears, and we can see that every 8 studs the position is being updated. Now, to make the target part's position move smoothly for the client, what I'm going to do is create a variable at the top here saying target equals nil, and when I activate the tool after I have sent the position to the server, I'm going to wait for the server to position the target part into the tool. So I'm going to say target equals tool wait for child target, and now over here outside of the magnitude greater than 8 if statement, I'm going to position the target part. So if we test the game again, we can see from the client's perspective, the target part gets updated very quickly and smoothly, where for the server's perspective, the target part is updated slowly. You may feel that 8 studs is a bit too much, so we can reduce this down to 2 studs. And now that we've set the magnitude to 2 studs, it's a lot more smoother for the server. I'm now going to delete this print because I no longer want to see it. Now that we've finished the visuals of the tool, now let's work on the code for slicing parts. So if we imagine this is the part the player is trying to slice, and they move their mouse across the part like this. Now we want to get the position where the mouse first touched the part and the position where the mouse exited the part, and then we're going to use these two positions to create the slice C-frame. So to detect when a instance is being moused over, I'm going to create a new variable called ray instance, and inside of our heartbeat loop I'm going to check to see if the ray instance is not equal to the new instance that is returned from the ray function, and if it's not the instance, I'm going to update the ray instance to be the new instance, and I'm going to print the new instance. I also want to set the ray instance back to nil when the tool is deactivated, and if we keep our eye on the output, when I click on the base plate we can see it prints base plate, and if I drag the mouse to the spawn location it prints spawn location, and if I drag it onto my character we can see it prints the character parts, and if I drag it out of a part, for instance the sky, we can see it prints nil. I now want to create 2 more variables at the top, one being called ray start position and one being called ray previous position. And now when the instance is updated, mean we've just selected a new part, I'm going to update the start position, but I'm always going to update the previous position. So before we update the instance, I'm going to check to make sure this part is not equal to nil. And if the part is not equal to nil, we're going to cut this part. So I'm going to say, for now, I'm just going to say cut and pass in the instances name. So if I test the game again, and if I click on the base plate, we can see that nothing is printed to the output because the previous instance was nil, and if I move my mouse to the spawn location, we can see it says cut base plate, meaning that the previous instance was the base plate, and if I move my mouse off of the spawn location, it says cut spawn location because the previous instance was the spawn location. And now that we know when to cut a instance, I'm going to now create a C-frame, and this C-frame we're going to send to the server, and the server is going to use this C-frame to cut the instance. In order to create our C-frame, we're going to use the from matrix constructor. The first value this constructor takes is the position, and the position is going to be the center of the start and previous position, so it's going to be right here in the center. So let's first calculate the center position. So I'm adding the start position and the previous position together and dividing by 2, and that will give us the center position. The next thing the from matrix constructor requires is the x vector, and the x vector is describing the direction of the right side. So the right vector will be an arrow pointing in this direction, like this. And to calculate the x vector, all we're going to do is subtract the start position from the previous position. Now, by subtracting the start position from the previous position, it's going to give us an x vector that is this long in magnitude. And we're going to be using the cross product function, and what this function does is you give it two directions like A and B, and it will return the C direction. But for the cross product function to work, it's important that the magnitude of this arrow is equal to 1. So the magnitude would need to be 1. So if I print the magnitude of the x vector, and if I delete this cut print, so if we test the game and I cut from here to here, we can see that the magnitude was 11. And if I cut from here to here, we can see that the magnitude was 0.4. So that we can use the cross product function, I'm going to unit the vectors, like so. And so if we test the game again, and if I slice the spawn location, we can see that the magnitude is now 0.9999999, which is almost 1. And if I slice the small edge, we can see we get the same 0.999999, which is also almost 1. The next thing the from matrix constructor requires is the y vector, which is the up vector, and this is going to be an arrow pointing up like this. But currently it's impossible to calculate this y vector, so instead of calculating the y vector, let's skip the y vector and let's calculate the z vector, which is the look vector, the direction the part will be looking in. To calculate the z vector, we could use the tool's top part. So if we imagine this circle being the tool's top part, the z vector would be the direction from the tool to the center, and this would be the z vector. So while this works perfectly fine, I personally like to create the z vector from the camera, and while this is not 100% correct due to how the beam looks, it feels easier to control when the z vector is coming from the camera. So if we imagine that this is the camera, and we can have the z vector coming from the camera to the center position. So I'm going to delete this print, and now let's create the z vector. And here you can see I'm using the camera's position, but if you wanted to, you could use the top position and see how that feels to you, but I like to use the camera's position. You can also see that I'm uniting the z vector so that the magnitude is equal to 1. So if we imagine this being the center, we have the x axis and we have the z axes, and now we're going to use these two axes and use the cross product to calculate the y axes. So you can see we have the x, z, and we can use these two to calculate this up vector here. So to calculate the y vector, I'm going to simply do vector z cross vector x. So now that we have our three vectors, let's create our C-frame. And you may think this is going to work correctly, but it's not. There's a problem with creating the C-frame using these vectors. So when creating a C-frame using the from matrix constructor, the three vectors that we pass into the constructor need to be perfectly 90 degrees apart from one another. So the degrees from the y and x needs to be 90, and the degrees from the z to the x needs to be 90, and the degrees from the z to the y also needs to be 90. It might be easier for me to show you the 90 degrees on this website. So if we imagine the green arrow being the z vector and the red arrow being the x vector and the blue arrow being the y vector, we can see that there are 90 degrees between the green and the blue, and there's 90 degrees between the red and the blue, and there's 90 degrees between the green and the red. So they all have 90 degrees between them. Now, because we used the cross product, while the x and z vectors may not be 90 degrees, the c vector, meaning the y vector, will be 90 degrees from the a vector and 90 degrees from the b vector. So this y vector will be 90 degrees from the x vector and will be 90 degrees from the z vector. But it will not be 90 degrees between the x and z vector. And I can further demonstrate this if we imagine that the camera was over here, like this, and we imagined that the z vector was coming from over here. We can now see that this angle changes depending on where the camera is. So I'm going to ignore this z vector. So let's erase the z vector, and we already know that from here to here is 90 degrees. So I'm going to do the cross product again using the y vector and the the x vector, and that should give us a new z vector that does not point to the camera, and this vector should be 90 degrees from here and also 90 degrees from the y vector. So to do this, I'm going to overwrite the old z vector, and I'm going to cross the x and the y to create the new z. If we look at the from matrix constructor and read the description, it says if vector z is excluded, the third column is calculated as x cross y. And we can see that we're doing the same, x cross y. So technically we could just exclude the z vector, and now we don't need to do this because Roblox is going to do it for us inside of the from matrix constructor. So now that we have correctly calculated the C-frame, let's send this instance and the C-frame to the server. So the first thing I'm going to do is create a new remote event, and I'm going to call this event slice event. And now let's send this event to the server, and we're going to pass the Ray instance and the C-frame that we just calculated. And on the server side, let's create a function that gets called when this event is fired. So inside of this event we get the player, the instance that we want to slice, and the C-frame that the client calculated. I'm now going to create a part at the top, and this part is going to be stored in a variable called subtract part, and I'm going to set this part size, and I'm going to anchor this part. I'm going to set can collide to false and can query to false, and can touch to false. I'm also going to set this part's parent to workspace, and when we receive the slice event, I'm going to position the part's C frame to the C frame that the player sent to us. So if we test the game, we can see the subtract part in the center, and if I try to slice the spawn location from here to here, we can see that the part was placed correctly, so our C frame is being calculated correctly. And if I slice from here to here, we can see it was again positioned correctly. Now for the subtract async function to work, these pink parts do not actually need to be placed into the workspace. So instead of anchoring and setting all these values and parenting it to the workspace, we can delete all this, and I'm going to change the size to be large enough to fit the entire object that we're slicing. So a value of 100, 100 and 100 should be big enough to fit the parts that we want to slice. So if we remember from the start of the video, we need to place the subtract part once at the top and one time at the bottom. So let's calculate the C frame for these two positions. So to calculate these two positions, I'm going to first delete this, and I'm going to create a new C frame called C frame 1, and I'm going to use the C frame that the client passed to us, and I'm going to move it up on the up vector by 50, which is half of the size of the subtract part. And to calculate the other C frame, I'm going to do the same as this. So I'm going to copy and paste, but I'm going to call this C frame 2, and instead of adding, I'm going to subtract the up vector. And now I'm going to position the subtract part at C frame number 2. And now that we've positioned the subtract part, now let's subtract the subtract part from the instance that we're trying to slice. So I'm going to say union 1 equals instance, and I'm going to use the subtract async function, and I'm going to pass in the subtract part. And I'm now going to do the same but for the other side. So I'm going to copy and paste this code, but instead of using C frame 2, I'm going to use C frame 1, and this is going to create union 2. If you're wondering why C frame 2 makes union 1 and C frame 1 makes union 2 and the numbers are opposite, if we look here, remember that the top will create the bottom and the bottom will create the top of the union. So the numbers are flipped. Now if we read the description of subtract async, we can see that the returned object has no parent set. So we need to make sure that we parent these two unions, and we can do this like this, and I can do the same for the second union. So the two unions have the same parent as the instance that is passed in. And finally, we want to destroy the original instance so that only the two unions remain. So if we test the game, we can see we have the spawn location, and inside of this spawn location we have a decal. And if I slice this spawn location, we can see that the original spawn location was destroyed and was replaced with two unions. And because this spawn location was anchored, the two unions are perfectly placed where we cannot see the seams of the slice. But if I use the move tool and move this slice, this union, we can now see this slice. Another problem is it's possible for me to slice the tool, and I can even slice the handle of the tool, and once I've sliced the handle, I can no longer use the tool to slice the spawn location. And another problem is, if I attempt to slice one of my body parts, because these are mesh parts, we are unable to union mesh parts. So if I slice my leg, we can see we get an error and it says part type not supported. So to prevent most of these problems, what I'm going to do is create a new folder, and I'm going to name this folder Slice, and inside of this folder I'm going to create a part, and I'm going to slightly adjust the size and adjust the position. Like so. And now I'm only going to send the slice event if the instance is not equal to nil and the instance is not anchored, and if the instance is a descendant of the slice folder. So now it's not possible for me to cut my own tool and for me to cut my character, and I can't cut the spawn location and I can't cut the base plate, but I can cut anything inside of the slice folder. So I should be able to cut this, and like this, and like this. Now be warned that hackers can send this event to the server and they don't care what you have written inside of your local script. So in order to prevent hackers, you need to make sure you do your checks on the server side as well. So you would check to make sure that this instance is inside of the slice folder. You will also want to check to make sure that this instance is anchored, and this way, no matter what the hacker sends to the server, we're doing the checks on the server side, so we will not blindly listen to what this event says. In order to prevent this video from getting too long, I'm not going to do any checks on the server side, but I do recommend that you watch my Stop Hackers Exploiters video so that you know how to prevent them from exploiting your events. Let's now improve our slice script. So if I slice down the center, now our part has been sliced but we can't see it, and if I push it we can now see the slice. So in order to prevent this from happening, I'm going to add a bit of force to push the two parts away from each other when the two unions have been created. In order to do this, I'm going to use the apply impulse at position, and this requires us to provide a force vector and a position for where the force is going to push from. So let's first calculate the direction of the force, and to do this I'm going to create a new variable called direction, and I'm going to use frame 1's position, and I'm going to subtract it from the center position, and I'm also going to use unit to make sure that this direction has a magnitude of 1. And I'm now going to calculate the direction for the second union, so I'm going to copy and paste, and I'm going to call this direction 1 and this is going to be direction 2, and instead of using frame 1 I'm going to be using frame 2. And now let's apply the impulse. So I'm going to say union 1 apply impulse at position, and I'm going to use the direction 1, I'm going to multiply it by 10, and I'm also going to multiply it by the union's mass, and I'm going to use the center as the position for where to apply the impulse. The reason I'm multiplying by the union mass is I want the force to be normalized based on the union's size. So small parts will have a small force applied to them, while large parts will have a large amount of force applied to them. I'm now going to do the same for the union 2, so I'm going to copy and paste and change this to union 2, and I'm going to change this to direction 2, and change this to union 2. And so if I slice the part again from the center, we can see that nothing happened. And the reason this is happening is we can only call the apply impulse function after we have set the parent. So I'm going to slightly reorder my code, and I'm going to set this up here like this, and then I'm going to parent the unions first, and I'm going to apply the impulse after I have set the parent. You may also be wondering why I placed the two subtract asyncs at the top next to one another, and the reason for this is these functions are async functions. So what that means is they have a delay, so you can think of them as having waits inside of them like this. And if I had placed this code over here instead, what would have happened is we would have created union 1, we would have parented union 1 and applied a false, and now as we're creating union 2 there would have been a wait. So while we're waiting, this union is now moving before union 2 has had a chance to even be added to the workspace. So to prevent this from happening, I make sure to first create both unions and then apply any effects to the unions after both of them have been created. There is also another problem that we have due to the fact that these are async functions, and that is if this instance object is moving and we subtract from the instance object, because this function is waiting, by the time we come to the second subtract, this instance object may have slightly moved, and now the two instances are not perfectly aligned. So to fix this problem, what I'm going to do is anchor the instance before we call the subtract async. And because we're now subtracting from a anchored instance, our unions will now also be anchored, so we need to make sure to unanchor our unions. And I'm going to do the same for the union 2. And now if we slice the part, there should be a false applied, pushing the two parts away from each other. Now let's add support for attachments. So if I open my slice folder, and inside of this part, if I add an attachment, and if I position this attachment to the top left corner, like so, and inside of this attachment, if I create a particle emitter, and if I run the game and look inside of workspace and look inside of the part, we can see the attachment with the particle. And if I slice this part, we can see that the part was destroyed and two unions take its place, and the attachment inside of the part also got destroyed. So that the attachment does not get destroyed, after I have created the two unions, I'm going to loop through every child inside of the instance. And if the child is not an attachment, I'm just going to skip that child. So if child.className is not equal to attachment, then continue, which means to skip. But if the child is an attachment, I'm first going to save the attachment's world position in a variable called position. I'm now going to use this position to calculate the distance from C-frame 1 and C-frame 2 to determine which union this attachment needs to go in. So to do this, I'm going to do local magnitude 1 equals cframe1.position negative position dot magnitude, and I'm going to do the same for cframe 2, so magnitude 2 cframe 2. So now what I'm going to do is say if magnitude 1 is less than magnitude 2, which means that union 1 is closer to the attachment, I'm going to say child dot parent equals, and I'm going to parent it to union 1. Else, I'm going to parent it to union 2. And once we've changed the parent of the attachment, it's important that we set the attachment's position to the same world position that it was before. So I'm going to say child.world position equals position, which is this position here that we saved at the start. And if we test the game again, we can see the attachment inside of the part, and if I slice the part, we can see that this attachment was placed into the correct union, and here we have the particle emitter inside of the attachment. Now that our tool supports attachments, let me show you how to make something like a tree. So inside of the slice folder, I'm going to create a new model, and inside of this model I'm going to create a part, and I'm going to anchor this part, and I'm going to create another part, and I'm going to move this part to be above this part. So this bottom part is anchored and this top part is not anchored. I'm now going to create an attachment for both parts, and I'm going to move the attachment in the top part to match the position of the anchor on the bottom part. So I'm going to copy the world position and paste it as the world position for this attachment, and I'm going to rename this to base, and inside of this attachment I'm going to create a rigid constraint, and I'm going to set attachment 0 to this attachment here, and set this attachment to this attachment here. And now if I play the game, we can see that the top part is welded to the bottom part, and as I slice away, the parts fall away. And we can see that inside of this union there has an attachment with the rigid constraint, and if I slice this union, the union is destroyed and a new one is created in its place with the same attachment and rigid constraint. Sometimes when slicing parts, you may notice that the part flickers. To help prevent this flickering, what we can do is, after we've created the unions, we can set can collide and can query and can touch for the original instance to false, and then instead of destroying the instance instantly, we can destroy it after a small delay. So if we do game.debris add item instance, and we can tell it to destroy it after 0.1 seconds, and now that should help reduce the flicker when changing from the original instance to the two unions. You may also notice that some of the properties do not get copied over to the union. So we can see that the leaves part of the tree has massless set to true, but after I slice the leaves and we click on the union and we check massless, it's changed from true to false. So the properties were not copied from the original to the union. So to fix this, what I'm going to do, after I have set the anchored, I'm going to copy the massless property from the original instance to the union. And I'm going to do the same for union 2. So union2.massless equals instance.massless. Another small change I want to make is when I'm slicing with the tool, I want the ray to ignore the character, because sometimes when slicing it's easy to clip onto the tool and activate the slice early. So in our raycast perims, when we equip the tool, I'm going to add the character to the blacklist. So you can see filter descendants, and I'm using the tool's parent, which is the character. And now my character will not get in the way when slicing. Now let's improve the mobile support for our tool. So the first thing you'll notice is when I'm swiping with the tool, the camera moves as well. Now this is not a very big problem and we could ignore it, but I'm going to show you how to fix the camera in place so that when you swipe the camera does not move. So the first thing I'm going to do is create a new variable called camera type equals nil, and then when the tool is activated I'm going to check to see if the input type is touch, and if the input is touch, I'm then going to save the current camera type to the camera type variable, and after I have saved the camera type I'm going to change the camera type to fixed. And now when the tool is deactivated I'm going to check to see if the camera type was set, and if the camera type is not equal to nil I'm going to change the camera back to the camera type it was before the tool was activated, and then I'm going to set camera type back to nil. And now we should see that when I use the tool I can no longer rotate the camera, but if I unequip the tool now I can rotate the camera. Another problem we have is the D-pad now conflicts with the tool. So if I try to walk forward we can see that the tool is activated and the camera is fixed. If we look inside of players, and inside of my player we look inside of player GUI and touch GUI and touch control frame, we should see a frame called dynamic thumbstick frame. So we want to prevent the tool from working if the touch touches this frame, and to detect if the touch is on that frame we're going to use the get GUI objects at position. So the first thing I'm going to do, at the top of my local script I'm going to get the players service, and when the tool is activated, before I set the camera type and if the touch input type is touch, then what I'm going to do is get the GUIs at the touch position, which is the input position, so you can see I'm using the get GUI objects at position, and I'm using the inputs X position and Y position, and this is going to return a table with all the GUIs at that position. I am then going to loop through every GUI I am then going to check the name of the GUI, and if it matches the name that we want, which is dynamic thumbstick frame, Then I'm going to return out of this input begin function, preventing the rest of the code from executing. And now if I click and drag over here, I can use the tool, and if I click and drag over here, I can walk, and the tool is not activated. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.